Today we are going to solve the problem 4.25 of Griffith third edition Introduction to Quantum Mechanics. This problem consists of three parts. First, we will see the part A. What is the uh, value of L plus, that is the rising operator act on YLL? No calculation is allowed. Actually, this is YLM. Sorry, this is YLM. I will use different color. Uh, this is YLM. YLM. So we know M varies from minus L to plus L in step up 1. So the maximum value is top rank is plus L. So you cannot raise the level more than this. So naturally this will be 0. Then use the result of A. Use this result together with equation 4.130 and the fact that LZ when LZ act on YLL, it will gives rise to the eigenvalue HL with the eigenfunction YLL. To determine YLL, which is a function of theta and pi, up to the normalization constant. This is part B. We know it is given as per a problem LZ, when LZ act on YLL, this will give you MH cross. But here the M value is maximum value L. So this will be LH cross with the eigenfunction YLL. So what is LZ? You know, by definition, LZ is equal to H cross over I delta over delta psi. So this is the LZ. Then when it act on YLL, what will happen? It gives you the eigenvalue HL and eigenfunction YLL. Now uh, you cancel H here, H cross and H cross here, and bring this L to the other side. So this will become IL. So and also T pi to the other side. So this will become delta YLL over YLL. I am bringing YLL to the other side. Then the right hand side is this IL T pi. I am swapping this YLL and T pi. So that is delta pi. So if you integrate, what will happen? Right hand side will become natural logarithm of YLL, and sorry, left hand side will become natural logarithm of YLL, and the right hand side IL pi plus integral constant. So you remember that this YLL is a function of theta and pi. However, the LZ varies, increases the state of mth state, so which depends on pi. So this integral constant is f of t, which is a function of theta. Sorry, f of theta, which is a function of theta. And if you take uh, exponential both sides, this will become YLL and this will become f of theta e power plus IL pi. So this is the value, that is wave function YLL is equal to f of theta e power IL pi. Then we will move further. As given in the problem, the rising and lowering operator is equal to plus or minus h cross e power plus or minus I pi multiplied by delta over delta theta plus or minus I cot theta delta over delta pi. The upper sign is for rising operator, the lower sign minus is for lowering operator. So now you know the when rising operator act on YLL, we got the value 0 as from the part A. So now what will happen when L plus act on YLL? By definition, L plus is equal to H cross e power I pi plus I pi, of course. Delta over delta theta plus, because we are taking only upper sign, is a rising operator, I cot theta delta over delta pi. And YLL, what is YLL? In section A, we have seen YLL is equal to f of theta. Of course, f of theta in this case is a constant. It does not varies with the LZ operator. So f of theta e power I L pi, which is equal to 0. Now you bring f of theta, this entire thing inside the bracket. So first you differentiate this with respect to theta. Only f is a function of theta, so you can differentiate delta f over delta theta, and you keep e power il pi as it is because it does not depend on theta. Similarly, in the next term, it depends only on pi. So you differentiate this exponential term and keep I cot theta as it is. I cot theta I am keeping as it is. Then f of theta also I am keeping as it is. So I cot theta I am keeping as it is. F of theta I am keeping as it is. I am differentiating only the exponential term, which will be IL, that exponential term. So this is exponential term multiplied by IL, so not F, exponential term IL. So now you bring this to the other side, so this will be 0. Then you will get delta F over delta theta, then this exponential term. Here you have I, another I squared is minus 1, and here you take L cot theta, then this exponential term, yeah, that is e power I L pi f of theta, which is equal to 0. This can be written as delta f over delta theta is equal to, because I am bringing this to the other side. So L cot theta f of theta. Now you bring f of theta to the left hand side and delta theta to the right hand side. Then this will become delta f over f, which is equal to L cot theta delta theta. Now we will simplify this. We can do the integration part. Now we got this expression. If we integrate both sides, that is left hand side and right hand side, I'm taking L outside. If you differentiate this cot theta, integrate the cot theta with respect to theta, then you will get natural logarithm of sine theta, and this L is here. Then the left hand side, if you integrate delta f over f, you will get the natural logarithm of f. So now if you can take exponential both side. If you take exponential of this one, then you will get f of theta. And the right hand side, if you take this is integral constant L, natural logarithm of c plus L, natural logarithm of c, natural logarithm of sine theta. This can be written as sine power L theta, and this if you take exponential, this is normalization constant A. So y L of L, which is a function of theta and pi, just now we have seen is equal to f of theta exponential I L pi. Now we have seen this f of theta is equal to a sine power L theta e power this exponential term e power I L pi. Then we will move on to the next section. Section C is determine the normalization constant by direct integration. So this is double integration because y depends on theta as well as pi. So theta varies from 0 to pi and pi varies from 0 to 2 pi. That is this. This can be written as modulus square of y multiplied by sine theta d theta d pi. Now d theta, as I said, varies from 0 to pi. This varies from 0 to pi. Then d pi varies from 0 to 2 pi. And we know the YLL is equal to A sine power L theta e power I L pi. So if you take modulus square, this exponential term naturally will go away. Then you have to square the first two terms. That is A squared sine power 2L theta. Already there is one sine theta, d theta, d pi. Now, t pi, as I said, it varies from 2 pi, 0 to 2 pi. So, first integral will go away with value 2 pi. So, I have multiplied this by 2 pi, a squared by 2 pi. Then, remaining integral is 0 to pi. Then, sine 2L. Here, I have one more sine theta. So, 2L plus 1 theta. Uh, d theta, which is equal to 1. We will simplify it further. Now we got this integration. The value of this integration is a standard one, so which is equal to which I have shown in yellow color bond. That is 2 times 2 power 2L multiplied by L factorial square divided by 2L plus 1 factorial, which is equal to 1. Here you can see this 2 in it multiplied by this 2 pi will become 4 pi. Remaining term I have kept as it is. Then A is equal to, if you bring this term to the other side, you will get this 2L plus 1 factorial will come into the numerator. Then in the denominator, you have to take square in order to find A. So this will become uh, 2 power 2L will become, because you have to take square root 2L multiplied by L factorial, because this is L squared factorial. So this will become L factorial. Then if you take the square root of 4, you will get 2. And the square root of pi, I have taken inside the square root. Now you can see 2 into 2L, 2 power L will become 2 power L plus 1 multiplied by L factorial, and remaining thing, square root term as it is, 2L plus 1 factorial over pi. Here, this minus 1, what I have given here is arbitrary phase factor. So we have found the normalization constant. Thank you very much for watching my video and supporting me continuously. Thank you very much.